Hey everybody, your Friendly Math Tutor here with video 5 of our SAT one-sheet breakdown series. So the PDF files for both the one-sheet and the examples from this particular video are linked below. Make sure you subscribe to the channel, check out our Instagram, Facebook, and TikTok, where we have a bunch of videos related to SAT, some for BC Calculus, and other subjects that we're going to keep putting videos out for. All right, so let's dive into the one sheet for today. All right, so in our one sheet today, we're going to focus on important concepts. In the last video, we looked at polynomials and complex numbers, but this time we are going to look at basic geometry and exponents and radicals. So let's start with some basic geometry. And our topics here are vertical angles, linear pair, parallel lines, and the triangle inequality. So let's start with some vertical angles. And the way vertical angles work, again, I call this basic geometry. These are things you definitely would have learned in a geometry class, and they are very important for the SAT. And when we have an X here like this, the angles across from each other, so 1 and 3 and 2 and 4, are what we would call vertical angles, and vertical angles are always congruent to each other. So in this problem, we also have to know another geometric concept where the angles of a triangle add up to 180. So if you look at the triangle at the bottom, 60 plus 40 is 100. That leaves 80 left over for here. And here is where the vertical angles come in. And that is going to mean that this angle is also 80 because of vertical angles. And now we have 80 plus 45 is 125 plus z has to equal 180. So therefore, if I do 180 minus 125, that should give me 55. All right, so we use the angles of a triangle, add up to 180, and then we use the vertical angles here. So that's one way. Vertical angles will very rarely be the whole problem. They'll usually be one small part of the problem. So anytime you see an X like this, you're probably going to be using vertical angles. Okay, let's keep it moving, and our next topic will be linear pair. So a linear pair is just a pair or two angles that lie on a line. And when they do, they are supplementary, which means they add up to 180. So in the figure above, what is the value of b? Well, these are a linear pair, so 5b plus b would have to equal 180. This is a pretty straightforward problem. So 6b would equal 180, and divide by 6, and b would equal 30. All right, so again, pretty straightforward problem. Just wanted to illustrate the concept of linear pair and how you would use it with some variables. Next up, we've got parallel lines. So parallel lines, when you were in geometry, you learned a lot about alternate interior angles, corresponding angles, alternate exterior, same side interior. You don't need to know all that vocab for the SAT. What you do need to know is that whenever you have a parallel lines cut by a transversal, you're going to have 8 angles that are created, and they're going to create either acute angles or obtuse angles. Each acute angle is going to be congruent to each other, each obtuse angle is congruent to each other, and every obtuse and acute angle are going to add up to 180. If you can know that, then you don't necessarily need to know all the vocab. If you know the vocab, that's wonderful. But the SAT is not going to ask you questions about the vocab. You're just going to have to know what the angles are. So if you look at a problem like this, we've got a triangle. So we're going to end up using the sum of the degrees of a triangle again. But before we do that, there's a couple different ways to look at this. I'm going to look at it this way. This angle is 50 degrees. And if I look at this as the transversal, I just covered up P, but we'll remember that it's there. If that's the transversal by our parallel lines, then notice this angle too is an acute angle. So this angle has to be 50. It turns out to be corresponding angles. But again, you don't need to know that. You just need to know that they're both acute, so they're going to be congruent. So then I know that 50 plus this P that I covered up plus Q, that has to equal 180 because we have a triangle. And if they only want p plus q, then all I have to do is take 50 away to this side, so that gives me 130. The other way to do this would be to say this. Actually, let me just erase this. So just to give you an alternative way to do this, if this is q, notice q is an acute angle from this transversal. And this is also an acute angle from the same transversal, so that has to be q. And now p, q, and 50, they all lie on a straight line. So once again, we get p plus q plus 50 equals 180, which is the exact same equation. So it's just these are three angles along a straight line as opposed to three angles of a triangle. But we still end up getting p plus q is 130. So you either notice that q goes here or that 50 goes here. Either way, we're using the same idea about how angles along a parallel lines and along a transversal of parallel lines, how they're related to each other. All right, let's jump back to our last one, which is the triangle inequality. The triangle inequality just says that the sum of the two shorter sides has to be longer than the longest side. This has nothing to do with right triangles. This is just triangles in general. All right, you can't form a triangle if this fact isn't satisfied, all right, or this criteria isn't satisfied. You won't even have a triangle. So what we do is this one says which of the following cannot be the lengths of a triangle. So for A, 3 plus 5 is greater than 7, so that works. So it's not the answer. 3 plus 24 is definitely greater than the other 24, so that is not the answer. 4 plus 6 is greater than 9, so that's not the answer. But in D, you have to rearrange it a little bit. There's two shorter sides. 4 plus 2 is not greater than 7, so that cannot be a triangle. So therefore, that is the answer. All right, that concludes our geometry, our basic geometry on the one sheet. So let's head back to the important concepts. And our last important concepts is exponents and radicals. So first, let's start with our exponent laws. So we got our product property, our quotient property, and our power to a power property. So whenever you multiply like bases, you add the exponents, divide like bases, and you subtract the exponents, and you raise a power to a power, you multiply. So let's see how we can put that into action on a couple of examples. So if we have 8 to the n times 4 to the second, well, I can't add those exponents because they don't have the same base. But I can make them have the same base. 8 is 2 to the third power, and that's being raised to the n. Times 4 is 2 to the second power, and that's being raised to the second power. And that all equals 2 to the 10th. So now I'm using the third property, the power to a power. So that's 2 to the 3 times n, times 2. 2 times 2 is 4. Whoops, 2 to the 10th, not 10. And now I'm using the product property. So 2 to the 3n times 2 to the 4th is 2. I add the exponents and I get 3n plus 4 equals 2 to the 10th. And then what happens is 3n plus 4 has to equal 10. Because if I have 2 to a power equals 2 to a power, those powers have to be the same. So this is just a pretty straightforward equation to solve. So I take 4 away from each side, so that is 6, and then divide by 3, and so n has to equal 2. All right, so that's one way for us to use our exponent laws. Let's take a look at another example. So in example 2, this one we're going to use the power to a power property again. So we have x to the 2a minus 3 to the second power, which means the exponents, the 2a minus 3 has to be multiplied by 2. And then I have to distribute. So I really get 4a minus 6 equals x to the 14th. And then we use that same property that if x is being raised to a power and to another power, those powers have to be the same as each other. So 4a minus 6 has to equal 14. And then I add 6 to the other side, so 4a has to equal 20. And I divide each side by 4, so a would have to be 5. All right, so that's just a couple ways that we can use our exponent laws to solve some problems. So let's now take a look at other types of exponent problems. So let's look at exponent and radical form. So what happens here is when you have something in radical form, so in this case they have n, the nth root of x to the p, and they're saying that's the same as x to the p over n, the numerator is always the power and the denominator is always the root. That's how we can switch back and forth. So when they have x to the 2a over b, 2a is the power and b is the root. That means we're taking the bth root, that's a weird thing to say, to x to the 2a power. All right, so that looks like it is simply just answer choice B. So you're just going to have to know how to switch back and forth between the radical form and the exponential form. All right, let's take a look at our last example on negative exponents. So a negative exponent is not a negative number. It really is just a fraction. So x to the negative power is 1 over x to the positive of that power. And we could do this a couple different ways. I'm going to do it a little bit of the long way, and then I'll show you a couple of shortcut ways. So the longer way would think of 2 to the negative fifth is really 1 over 2 to the fifth. Divided by 2 to the negative third is really 1 over 2 to the third. Then I do the keep change flip, so it's 1 over 2 to the fifth times the reciprocal of this, which is 2 cubed over 1. So then I end up really getting 2 to the third over 2 to the fifth. And then I can subtract our exponents, which it really is 2 to the negative 2. And finally, 2 to the negative 2 is 1 over 2 squared, and 2 squared is 4, so it's 1/4. I definitely did it the long way, so anybody who's kind of yelling at the screen saying, why is he doing it so long? I just wanted to illustrate all the concepts here, that anything to the negative power is 1 over that to the positive power, the whole keep change flip, then the division property where we subtract, and then turning it back, all right? But I definitely think there's a quicker way, so I'll do that right now. We could just start with the division property, which says we could just subtract our exponents. You do have to be very careful, though, because a lot of us tend to make mistakes when we're doing subtracting negatives. So we're subtracting these numbers. So we're really doing -5 minus -3, which is really -5 plus 3, which is -2. So we can get 2 to the -2 right away as long as we do it appropriately, and then realize that that's 1 over 2 squared, which is really 1 over 4. So that's the way that I would do it. I just wanted to show the other way to, again, kind of further go over the whole negative exponent and the division property. But it would make more sense to start with the division property. All right, so that is the end of this part of the one sheet. So we've got some basic geometry. You need to know vertical angles and linear pair. You need to understand how angles are formed when there's a transversal cutting parallel lines. We definitely need to know the triangle inequality. And as far as exponents and radicals, know the exponent laws, know the exponent and radical form, how to go back and forth, and certainly an understanding of negative exponents is going to be really useful. Okay. All right, so I hope that was helpful. Check out our other videos on the rest of the note sheet and all the examples that go along with that, really like the in-depth explaining that we're doing of this one sheet to help get you ready for your upcoming SAT. Also, check out Instagram, Facebook, and TikTok for other SAT videos or even BC calculus videos, as well as whatever other videos that we continue to put out for all the different math subjects. All right, again, hope that helped.